Okay, so let's see the third question. Third question is count of unfinished task after each shift. Okay, so we have given right to integer array task and shift. Okay, task I represent the ith task and j represent the jth shift. So always read the question properly. Okay, okay, then the task must be processed in from. Okay, we have to do the task from left to right. Okay, so we have to do task from left to right. Okay, then there's a carryover. If a task is not completed, it starts within say if a task not completed, right? It's carryover. Okay. Okay, then the next thing is right, restart. If all tasks are completed, immediately restart. Sorry, shift ends, time is discarded, and restart from the task zero. Okay, restart when all tasks completed. So what does the question say? So this is basically right. We have given a task so I. We have given one shift so I. So this is 144, 144. Okay, so 914. So what it means, see, in each shift we have to work. Okay, so then we are going to consider this shift, right? So our answer array, right? Answer array is of size shift. Now tell me, in this first shift, how much work I can complete? See, 9 unit. So 9 unit is what? If I have to find in the task, how much task I can complete in this 9 unit of time. So I can do one. Can I do second? Yes. Can I do third? Yes. So I can complete this, right? Okay. So after this, right, how many tasks are left basically? Okay. See, after finishing this task, how many are left? Zero, because I completed all three, right? All three completed. Okay. Now let's check the next one. Okay. In the next one, we have 1 unit of time. Okay. So which task I can complete in 1 unit of time? 1 unit, only one task, right? Only first task, right? So how many are left? Two tasks are left. Okay. So two tasks are still left, right? So then we'll move to the next one now. Let's see. After two, then we have four tasks to do, right? Now we have, sorry, 4 unit of time. Now in this 4 unit of time, how much the task I can complete if I start from this one? See, this one I completed, right, already. So I'll have to start from this one. How much I can complete? One more I can complete, right? Okay, so how much is left? One. One we can complete, right? Then left equals to what? One. So this should be 0 to 1. So let's check. Okay, 0 to 1. Now let's see. Now if we start checking, right, if we for each step, if we start looping over the task, then it takes us the time complexity of n, right? Cross of n, right? This is for save and this is for task. So obviously this will not work. So right, we have to find one optimized approach. Okay. Okay. So now tell me one thing. Just see, this is my shift, right? S1, S2, S3 till Sn, right? So this is my task. So simply let me write this task here. T1, T2 till Tn. Now I can complete, right? I can complete S1 unit of work. So I have to find, right, the till where sum is S1, right? What hint it gives it, right? Prefix sum, right? See, if I have to tell efficiently till where, right? Till where I have this S1 task, right? So that's obviously right prefix sum. So can I say, right, if I take its prefix sum, I will write some pt1, pt2, pt3, and so on ptn. If we take the above example, that is right 144. So if we take the above example task, that is 144, then our prefix is what? 159, right? Okay. Now for S1, right, I can complete S1 unit of 5. So I have 9, right? So I have to find upper bound of it, right? So because all tasks, right? All tasks that take time, right? Less than equals to shift of I can complete, right? See, can I complete all tasks that take this time that is less than equals to S1, right? So in our example, this was 9, 1, 4. Can I complete all tasks which take less than 9? So how many tasks which are smaller than 9? 3 tasks. Okay, so left is 0. Okay, now see for 1. Now for this 1, how many tasks I can complete? 1 task. What is the upper bound, right? Upper bound of 1 is what? Upper bound of 1 will be our this 0, right? Okay, so left is what? 2 tasks are still left. So I'll do 2 tasks. Now see, when I will go to 4, I will see this one we already included, right? But all task tree is not empty. So for this 4, the total, right? Total time, right? Is 1 plus 4. Why? See, because task is not empty, right? See, if task is not empty, we have to consider the previous one as well, right? Okay. So, or you can say like this, okay? So if it takes one previous if take, for this one take, if I completed 1 unit of time in previous one, and if I again take the same one, then this 4 plus 1, 5, and 1 plus 4, 5, this remains the same, right? That's why. So if I take 5, then I need to find the upper bound of 5. Now, upper bound of 5 equals to what? 1. So left equals to what? 1. Only 9 is left, right? So this will do 1. So the algorithm is simple, right? First find, right? Step 1 is what? Find prefix of task. Okay, now for each shift, right? For each shift as I write, right? For each shift from I equals to 0 to n, what we are going to do, see, what is my time, right? So we'll write in my current shift, right? I will add whatever the shift that I'm working on previously until the entire task set is completed. So I'll add task I, right? Then we need to find the upper bound, right? So let's say x equals to, right, upper bound of what? Upper bound of our shift from the prefix, right? Then task left equals to what? Answer of I equals to what? See, total task, right? The total task minus the upper bound one, right? One index. So this is basically the whole approach, right? Upper bound, so I hope you guys know the upper bound. Upper bound of x, right? Strictly number of elements, strictly greater than x. Okay. So this is the whole question. Then the time complexity is what? See, this takes of n time. This one runs in n basically. This one runs in log n basically. So the final time complexity of n log n. Got it? Yeah. So let me show you the code part as well. See, task, we declare the task dot length. We make the prefix. Answer file is the length of shift. See, length of shift. We prepare the prefix. See, this is upper bound. Okay. We have our shift. We add the shift, right? Add total shift count until, right, tasks are completed. Okay. What is this one? This part is basically discard, right? Discard when all are completed. Okay. This part is basically left, right? So this is the whole solution basically. So pretty much simple question, huh? Okay.